Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the Kubernetes custom controller that we have been writing. In one of the previous videos, we actually completed that controller. But in this particular video, we are going to look into how we can run that custom controller from inside of the Kubernetes cluster. So we wrote that Kubernetes custom controller and we were running that on our local machine, I would say on local terminal. But in this particular video, we are going to look into how we can package that custom controller and get it deployed on Kubernetes as a pod, let's say. So to do that, there are some steps, and first of all, we will have to containerize our application. So that is what we are going to do first, and then we will be moving into other steps. To containerize it, what we are going to do is, let's just go ahead and try to create a file named Docker file, and Docker is the tool using which we are going to containerize our application. So we are going to use Alpine as base image, and once we have Alpine, we can just copy the binary into the path of this base image. So let's just copy, I would say, expose to user local bin and expose. So what this command is doing, it's just copying new files to the images file system as this says. So expose is going to be copied in this base images file system, and once we have that, what we can do is we can just set the entry point, and in our case entry point is going to be this binary that we just copied. So this should work. Let's just go ahead and try to create a binary for our application. Now there are chances that you might argue that this is not the correct way to containerize our Go application, and I would agree with you. There are a lot of ways to do that. For example, instead of creating the binary separately, you can include that step in this Docker file itself. So that's totally fine. We are not discussing about best practices to containerize Go applications, so that is the reason we are not focusing about that. So let's just go ahead and try to create a binary out of our application, and as soon as we run go build, this is going to get us the binary for our application, that is expose. Now we used this this flag to notify linker to do certain things. I'm not going to talk about this more in this particular video, but I'm planning to make a video about what are all the flags that can be provided to go build and then things like that. So it simply means that we are creating the binary in such a way that the interpreter would not be needed and things like that. So let's not worry about this. Let's assume that this is just going to get us the binary for our application. Now that we have the binary, we have the Docker file set up. Let's just go ahead and try to run docker build -tag, and I'm going to tag the image to be expose :0.1.0, and context is the current directory. So yeah, this should work. This particular binary has been copied to the base images file system. Now just to test the things, if this particular Docker file is working as expected, and when we run or when we create a container out of the Docker image, this particular binary is being run. Let's just run the container that we just built. So docker run, and this is the image. So yeah, it looks like things are working as expected, and our main.go file is trying to figure out the kubeconfig file that is not found and things like that. So yeah, things are working as expected. Now we have containerized our application, and all we have to do now is we are going to deploy this application in a Kubernetes cluster. So I already have a Kubernetes cluster set up locally using kind one node Kubernetes cluster. That is what we are going to use for this video. Now let's push that image to my container registry. So docker push, and this should work. As soon as this particular image is pushed, I'm going to create manifests to deploy this image on my Kubernetes cluster. So let's create a directory named manifests, and inside manifests we are going to create a deployment manifest that is going to run the image that we have just built. So kubectl create deployment, and we know that to run anything on a Kubernetes cluster we usually run that as a pod, and to manage pods we usually use deployments. If you are not sure about deployments and other resources, I have some videos about them as well. So kubectl create deployment, I'm going to name it expose, and this is going to run on a namespace, let's say expose, and the image that this deployment is going to run is this one. And I don't actually want to create the deployment, I want to create the manifest. So this is the command that we are going to use to do that. So deployment.yaml, and now we should have a deployment.yaml here. So it simply says this is going to run, this pod is going to run one container, and this is the image that is going to be run. Now let's just go ahead and try to create this deployment and see if things are working as expected. So kubectl create -f deployment.yaml, and it would complain because we don't have a namespace named expose. So kubectl create namespace expose, and if I apply the manifest once again, as you can see here, expose deployment has been created. So git pods -n expose, and it's in container creating. I'm also trying to follow the logs of this particular container just to see how things are going. Okay, so it looks like obviously container is running, but we are having some issues in the application. So let's go through these issues. So controller was started, but it says failed to watch deployment, failed to list deployment. It's forbidden for this particular service account. So whenever we run a particular application inside Kubernetes cluster as a pod, let's say, and that application tries to communicate to Kubernetes API server, that we are trying to do in this particular video, in that case the service account that gets mounted in the pod is used to authenticate the application against Kubernetes API server. So since we have not specified any service account, default service account is going to be used, and that is what we are able to see here. So it says default service account from expose namespace doesn't have permissions to watch the deployment or list the deployment. So this is the problem that we have. If you are even slightly confused about that, I have another video about how to deploy these applications inside Kubernetes cluster, and I will link that maybe in the description. So let's just go ahead, and now we will have to resolve this. So to do that, what we can do is since we are not specifying any service account for this deployment, default service account is being used. So first of all, let's do this. Let's specify a service account for the pod that is going to run. So service account name is equals to, let's name it expose-sa. And once we have specified the service account name, we will have to provide this service account enough permissions so that it can list and watch the deployment resources from all the namespaces, because that is what our controller is eventually trying to do. So let's just go ahead and first of all create the service account. So let's delete this because things are not working. So kubectl delete -f deployment.yaml, and let's create service account first. So service account -n, we are going to create it in expose namespace, and we are going to name it expose-sa. We don't actually want to create it. We want to look at the manifest first. So YAML and sa.yaml. So now let's go ahead and try to look into sa.yaml. So this is all we have created. This manifest is going to create a service account, and this is the same service account that we are going to use in our deployment. So once we have service account, the other two things that we have to create is a role and role binding. So role is the resource that is actually going to specify what are all the permissions that a particular user is going to have, but mapping between user and role is done by role binding. So in this particular case, instead of creating roles and role bindings, we will have to create cluster roles and cluster role bindings, because our controller tries to get the deployments from all the namespaces, not a specific namespace. Or in other words, our controller is listening for deployments from all the namespaces, and as soon as a deployment is created, it is going to expose that deployment. So let's just go ahead and try to do that. So kubectl create ClusterRole, and let's name it expose-ClusterRole. And since cluster roles are cluster scoped resources, we don't have to specify namespace, we have to specify resources. So resources are going to be deployment, and verbs that we want to support are list and watch. Now, before actually generating this manifest, another thing that I would like to highlight is, if you remember from previous videos, once we have the deployment, we want to, or we would create ingresses and services on the respective namespace. So that is another requirement, that is another permission that this controller is going to need. So let's specify that in this same cluster role itself. So deployment, service and ingress, and let's look at the ClusterRole.yaml. So let's just go ahead and open ClusterRole.yaml. If you see here, it says it can list and watch deployments from apps API group, and we don't actually want list and watch for ingresses, we just want create for ingresses, and similarly we just want create for services. And we did that because we are not actually listening, we are not actually getting or listing services anywhere, we are just trying to create the services and ingresses. That is the reason we are just specifying create verb for services and ingresses. But for deployments, we will have to specify list and watch, because we know that informer first time informer calls list and then it watches for the deployments. So now that we have cluster role, all we have to do is we have to create the cluster role binding, and let's name it expose-crb. And since this is mapping between user and cluster role, let's specify cluster role, and name of the cluster role is, we know this is the name of the cluster role, and we should be able to specify service account, and we specify service account in the format namespace colon name. So namespace is expose and name is expose hyphen sa. So this should work, and again let's create the manifest and hyphen o YAML, and we are going to store it in crb.yaml, and let's quickly have a look into this. So crb.yaml, it just maps this cluster role to this service account that we are using in the deployment manifest. So I think this should make sense now. So we have specified a service account in deployment, and that service account is mapped with a cluster role using ClusterRoleBinding. And in this cluster role, we have specified all the permissions that this controller needs. Now let's just go ahead and try to create the things now. So first create service account, and we are also going to create a ClusterRole.yaml. So ClusterRole has been created, and let's create ClusterRoleBinding now. And once service account ClusterRoleBinding has been created, let's go ahead and try to create deployment. So kubectl create -f deployment.yaml, and unknown field service account name. Okay, all right, I think, is it service account name? Sorry about this, there is a typo. So it's service account name. Now it's correct. All right, so deployment has been created. If you see here, we can see it's getting created, logs -n expose, and here we go. Now we don't see any error, add was called and things like that. Now if we go ahead and try to create a dummy namespace just to test the things, so kubectl create ns test ns, and we are going to get all the things from test-ns, and we are going to get ingresses as well from test-ns. And if I create a deployment in this particular namespace, let's say, so kubectl create deployment -n test-ns, name of the deployment is going to be nginx, and image that we are going to use is nginx. As soon as this deployment is created, we should get service and ingress created automatically. And here we go, add was called, and we got the service as well as ingress. And this is what our custom controller does. Now if we delete this deployment, delete deployment from test-ns namespace named nginx, obviously this deployment is going to be deleted, as well as the service and nginx ingress. So let's do that. Okay, so it looks like we have an issue here. So controller.go 126, let's just go ahead and try to fix this. Okay, it looks like we don't have updated code here. because in the, hold on, if deployment was deleted, sync deployment should not even get called. I am not sure why sync deployment was called, because if deployment was deleted, we should not get the deployment from API server, and in that case this particular logic should run. So getting deployment from lister. Okay, so sync deployment should not have been called. Alright, so after I paused the video and I tried to debug this, and I think I have the root cause now of this particular problem. So if you see here, it's failing on 126, and if we look at 126, we are trying to figure out deployment labels from a specific deployment, but in case of deployment deletion, this particular sync deployment function or method should not even get called, because in case of deployment, I have explained this in previous video as well. In case of deployment deletion, we should execute this particular block of code, and the reason is, it looks like we are neither getting the deployment from this call, nor we are getting this particular error, and that is the reason we are not able to execute this particular block of code. And the reason is, if you remember, when we try to call .get, this particular controller or the service account using which this particular controller is running should be able to get the deployments, and we did not specify that. So if you see here, for deployments we have just specified list and watch. So let's just go ahead and try to specify get here, and after we have specified get, in that case this particular call is not going to break. If it's going to break, it simply is going to say that the deployment is not available. So let's just go ahead and try to create the cluster role once again. So kubectl apply -f clusterrole.yaml. We should see that clusterrole has been configured. Now that clusterrole has been configured, if we look at the logs of controller once again, and let's go ahead and try to do the exact same thing once again. So delete ns test-ns, and we would create a deployment in this namespace, and then we would delete that to make sure that services and ingresses are being deleted. So create deployment, here we go. So add was called, and we are able to see deployment as well as service and ingress. Now if I go ahead and try to delete the deployment, so kubectl delete deployment from test-ns namespace and nginx. Now if you see here, we are at least not panicking out. So because this particular get call is being run successfully now, and it says API errors is not found, and then we go ahead and try to create the services and ingresses. That is the reason it says this particular service account cannot delete resource service from the namespace. So I think this makes sense now. Now what we are going to do is we are going to change the cluster role to specify that it has permissions to delete the services as well as ingresses. And now if I apply the cluster role once again, so cluster role has been configured, and we are going to do the same thing once again. So kubectl delete ns test-ns, we would create another deployment, and then we would delete that deployment. So create deployment, so if you see here, deployment has been created, everything has been created successfully. We are able to see logs in the controller as well. Now let's just go ahead and try to delete the deployment from test-ns namespace named nginx. Now everything should work as expected. Okay, so it still says that the service account cannot delete services. Let's check. Okay, so we have create and delete for ingresses, we have create and delete. Hold on, we messed up. So resources, it should be here. I'm so sorry about that. So delete should be inside verbs, but we specified that inside resources. So okay, now what we are going to do is we are going to let's say create another namespace. So kubectl create ns another test, and kubectl get all from another test, kubectl get ingresses from another test. So kubectl create deployment -n, this is going to be another test, and here we go. So we should see everything being created now. Add was called, and service and ingress was also created. Now if we delete this namespace, delete the deployment, hold on, let me just go ahead and try to delete the pod from expose namespace. We are going to get the logs of new pod now. So create deployment, another test, and we are going to create deployment in another test. So service as well as ingress has been created. Now what we are going to do is delete that deployment. So delete from another test, name this name nginx. I'm just deleting. Let's create the deployment and delete the deployment. So delete deployment from another test named Nginx, and here we go. Eventually, so we can see now that the service as well as ingress has been created. I'm sorry about this, it took so much time, I think, but yeah, I mean, at least we were able to resolve the issue, and we can see that when we delete the deployment, service as well as ingress is also being created. Just to test that, let's go ahead and try to create another namespace. So create namespace test2, and we are going to get everything from get all from test-2 and get ingresses from test-2, kubectl create deployment in the namespace test-2, and we should see everything being created in test2 namespace. And if we delete the deployment, everything should be deleted, even service as well as ingress, because we know that our controller created this service and ingress. So kubectl delete deployment from test2 namespace named Nginx, and here we go. So yeah, I mean, apart from that, I would also write a very nice little readme for this particular project, and I'm going to obviously check everything in or push everything onto my GitHub, so you can check the code there as well. And maybe the readme thing is going to be behind the scenes offline. So if you want to check that out, you can just go to the repo. If you think this is going to be helpful for someone, you should share the video. And thank you so much for watching. I'll see you in the next one.